Hi, this video is to talk about point estimation. Point estimation is a form of statistical inference. In point estimation, we use the data from the sample to compute a value of a sample statistic that serves as an estimate of a population parameter. For example, we use the sample mean, which is denoted by X bar. So I also get used to the terminology. X bar it means or is called sample mean, and the sample mean is the point estimator of the population mean, denoted by the Greek letter mu. Get used to this terminology. The Greek letter mu is the population mean, the X bar is the sample mean. So we want to know what the population mean is, but we don't know, then we use a sample, and then we determine the sample mean, and then we use that as the point estimator of the population mean. S is the sample standard deviation, and the sample standard deviation is the point estimator of the population standard deviation, denoted by the letter sigma. And the P bar is the population sample proportion. Sample proportion. That is the point estimated for the population proportion P. Okay, let's see an example. We have this company EAI employee data. Out of total number of 2,500 employees, a simple random sample of 30 employees and corresponding data about annual salary and management training program participation are shown in the given table in the next slide. Let's take a look. Okay, so here we have, let's say, we don't have the names of the employees, but it doesn't matter. So here's their annual salary and participation, yes or no, in the management training program. Again, more observations, more data about annual salary and participating or not in the management training program. And then we use this data to estimate the population, the annual salary and proportion of employees participating in training programs for this company. To estimate the value of population parameter, how the population is, we can compute the corresponding characteristic of the sample, referred to as sample statistic. Okay, let's take a look here. So we have, as an example, the sample mean for this data. Just to remind you, we selected 30 employees out of 2,500. We selected 30. And here's the data. If we compute the mean for this data, this is what we get. So the sample mean for the annual salary is 51,814. The sample standard deviation for the annual salary is $3,348. The sample proportion of employees participating in the management training program is 0.63, which means 63% of employees in that sample participated in management training programs. So these are the point estimators of how the population of employees is. Okay, so we are using this sample data to estimate how the full 2,500 employees are. Okay, you might be asking yourself why we would select a sample of 30 employees if we have data about all employees. That's true. This is just to illustrate to you and show you what the whole population information is and the estimate that we got looks like. So we can compare, and you can see the point here is we can use the population of 2,500 employees, so you can see the values and compare with the sample statistic and see that the sample statistic can really represent the population in a in a confident way. Okay, so that's the purpose. But in real life, if you have the full population, you only use the full population. But in many cases, we don't have full population, so we use a sample. And in this case, we are comparing the full population with the sample, just to illustrate to you the power of a sample. Okay, so in this case, the mean annual salary for the population is 51,800. The sample estimated by us, the point estimator sample mean is 51,814. The population standard deviation for annual salary is $4,000. The sample standard deviation for annual salary is 3,348. The population proportion having completed management training program is 0.6. I'm sorry. And the sample proportion having completed the same training program is 0.63 in the sample. So you can see that the estimate is very, very similar, very close to the true population parameter. Okay. The practical device. The target population is the population we want to make inferences about. Let's say consumers, fans, and I don't know, employees. The sampled population is the population from which we sample, from which the sample is taken. And whenever a sample is used to make inferences about population, we should make sure that the target population and the sample population are in close agreement. Okay? Okay, so they have to resemble one another. Let's practice. Let's open an Excel file and let me show you how to compute this sample statistics. So let me use, let me use this file. So here we have like managers or employees for the same company we are talking about. So if I go down, we have 2,500 employees. Where I go up, we have their annual salary if they participate in management training programs. Let me select a sample of 30. Okay, so I'm going to select the sample. Let's assume that's a random sample. I'm going to select the first 30 employees. I'm going to open a new Excel worksheet, and now we have a sample. Okay, the sample has only 30 employees. Okay, and their annual salary and training program. So okay, so how I compute the sample mean? You learn how to compute the sample mean in chapter 3, descriptive statistics. So the sample mean is equal to the average of the annual salary. Okay. Then we can compute the sample standard deviation is equal stdev.s, which is for sample, open parentheses. We select the entire data set, close parentheses, and that's it. Now we're going to compute the proportion. To compute proportion, let's say to compute the proportion, I need sample size. Sample size. Let's put it over here, which is 30. And then count of interest. My count of interest is I have to count those that had the training program, because I want to measure, I want to see the proportion of employees that participated in management training programs. So my count of interest is, let me put here ES. Okay, so that's I want to count how many said yes, and I'm going to show you how to count that using Excel. So to count, I have to do equal count if. Then you see there are two options here. Count if is the first one. Then we open parentheses, and then Excel asks for the range. So the range is the whole range of answers about training programs. And then you type comma, and then you open quotation marks and you type yes, because that's we want to count how many said yes and participated in training programs. 18. Now I can compute the proportion in this. So proportion. Now I have the piece of information that I need to compute proportion. So the proportion is equal to the amount of people that said yes divided by the 30 employees. So it's 0.6. Okay. So this is the proportion, this is the sample standard deviation, this is the sample mean. If we take a look and compare with this result, they're a little bit different because we're selecting a different sample. We're not selecting the same sample that we have here. Let's compare our results. So our sample mean is 51,288. This one 51,814, and the population is 51,800. So it is close. The sample standard deviation is 3,209. the true population standard deviation is 4,000, and the sample for the other sample is 3,348. Okay. Of course, there is variability because it's not the same sample. We're selecting a different sample. That's the reason we're going to have a different sample mean and different sample standard deviation. And finally, the population proportion is exactly the same for the population. It's 0.6 in our sample, is 0.6 better than the other sample. Okay, so that's how you find point estimators for the mean, standard deviation, and proportion using a sample.